Okay, everybody, now that we know what a three-dimensional figure is and how to name them, as well as how to create some of them by rotating a figure around an axis, we're going to start looking at the volume of them. So, first of all, volume is the measure of how much space an object takes up. So if we're taking a look at this cube right here, you're looking at how much space it actually takes up. So the front of it, if you're only looking at 2-dimension, that's what we would have called area. Okay, so length times width, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 square units there. But now, because we have a third dimension, this guy actually goes back, and he goes back by 1, 2, 3. So in the first row, if you're just kind of looking right here and down, we said that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 blocks. But if you go back another row, you're going to have another 9. And if you go back another row, you're going to have another 9. So really here, you're going to have 27 units cubed, because now we're working in 3 dimensions. Okay, so when you're working with area, you're working in 2 dimensions, which is why it's squared. But when you're working with volume, you're working in 3 dimensions, which is why it's cubed. Okay, and specifically, if we're talking about this guy, for a prism or a rectangular prism, most of us know the formula length times width times height, which would give us 3 times 3 times 3, which would get us back to our 27 units cubed. Now specifically, we're going to go apply that to any prism. So the volume V of any prism is V equals BH. Now the key here, do you notice that that B is an uppercase B, not a lowercase b? Okay, so typically if we're doing like area of something, we have base times height. Well, this isn't just the base, it is the area of the base. Okay, so volume of any prism is you take the area of the base and you multiply it by the height. Now, that can look like this on a straight up and down prism where the height is nice and neat, or if we take the prism and we kind of slant it, it can be the same thing, except now your height is going to be out here on the side, because keep in mind, your height always has to be a vertical distance that hits at a 90-degree angle, never the slanted distance. We never use that one for height. Couple examples. Now, first of all, this is a prism, okay, but it is a triangular prism. So we have to do the area of the base times the height. So I'm going to start with area of the base. And then the question becomes, well, what's the base? If you're thinking this is the base because that's what it's sitting on, no, that's not the base. Okay, we briefly discussed this in day 4, where the base of a prism has to be the 2 sides that are exactly the same. It doesn't necessarily have to be sitting on its base. Okay, so I'm going to get rid of this because that's not the base. Okay, the base here is actually one of these guys, because it's the same there and it's the same there. He's not sitting on his base, but that's the base. So the base here is a triangle, and we have to find the area of that triangle. Well, the area of a triangle, and again, you have a formula sheet or you're on a computer, Google how to find the area of a triangle, is 1/2 base times height. And notice now we're dealing with a lowercase b. So if I'm dealing with my triangle, this is my base, this is my height. So I'm going to do 1/2 8 times 7. Grab your calculator. 1/2 of 8 is 4 times 7. Wow, I am drawing a blank. What is that, 28? Okay, 4 times 7, yeah, 28. So the area of the triangle is 28. So the area of the prism is the area of the base And keep in mind, you just want one of them, not both of them. Okay, so we found the area of the base, that's 28, and then what you're going to do is you're going to take that triangle and you're going to expand it the whole way up. Okay, so the whole way up the side, which is 13. So area of the base times the height. So we're going to take 28 times 13, which is 364 units cubed. And that's your volume. Next one, find the volume. Okay, so once again, this is a triangular prism, and we need the area of the base times the height. Now look really carefully at what you think the base is. Okay, now if you think the base is the bottom, which is this rectangle, then that means I should be able to go up here and find the exact same rectangle. It's not there. So guess what? That's not the base. Okay, you need to find a shape that has the same exact shape across from it. So I'm looking and I'm finding this triangle. Because if I kind of go back to the back of my figure, there it is again. So your base, once again, is a triangle. And we need the area of that base. So triangle, 1/2 base times height. So we're going to do 1/2, looking at that triangle, base, 5, times height, 8. Okay, put that in your calculator, and I'm getting 20. Okay, so for the prism, we take the area of the base times the height. Now the question is, well, what's the height? Is the height 8? Is the height 5? Or is the height 3? Well, the height is the distance between the bases. So the bases are the triangles. So you go from the red one to the red one. You go from the red one to the red one. You go from the red one to the red one. That's the distance between the two triangles. So your height is 3. So your volume is 60 cubic centimeters, or centimeters cubed, however you want to write it. Okay, volume, area of the base times the height, which means we need to find the base. Okay, now once again, think to yourself, base, it has to be the same on the top and the same on the bottom. So if I come up here and I say this is my base, do I have the same exact one up here? Oops, I got off a little bit there. And the answer is no. Because if you look at the one on the top versus the one on the bottom, the one on the top is smaller than the one on the bottom, so they're not the same. So that is not your base. So can you find a shape that is the same on the top and bottom, or front and back, or side and side, that's exactly the same? And the answer is, okay, well, my base is actually this shape that's sitting in the front, because it has the same shape back here in the back. What is that shape? It's not a rectangle. It's not a square. That's a trapezoid. How do you find the area of a trapezoid? Okay, so the answer to that is, if you have your reference sheet, look at your reference sheet, or Google, is 1/2 the height times base 1 plus base 2. So let's think about this. 1/2 the height. What is the height on that trapezoid? That's right here. Straight up and down, 2.5. Times base 1 plus base 2. A trapezoid has two bases. One's on the bottom and one's on the top. So base 1, 5.6 plus base 2, 4.4. And that will get you the area of the trapezoid, which is the area of the base. So 1/2 times 2.5 times parenthesis 5.6 plus 4.4, close the parenthesis, hit enter, I'm getting 12.5. Okay, so the area of the base is 12.5 times the height of the prism. Now remember, the height is the distance between the bases. So we have to get from the base to the base. So from the front to the back, from the front to the back, from the front to the back, 4.2. So we're going to take 12.5 times 4.2 is 52.5 meters cubed. Okay, take a look at this guy. It's a prism. It doesn't come to a point, so it's flat and flat. And we have to find two bases that are exactly the same. Now, this guy's actually not that bad, because for the first time in all of our examples, he's actually sitting on his base. Because I can outline, and I've got the same exact figure on the top as I do on the bottom. So, base, what shape is that? And once again, that's another trapezoid. Okay, in order to be a trapezoid, the only qualification is that it has two parallel lines. So this top line is parallel to this line, and then the other two sides do something else. So if we go back, this line is parallel to this line, and then the other two lines do something else. That's a trapezoid. Okay, so area of the base, that's our trapezoid, is 1/2 times the height times base 1 plus base 2. So 1/2 times the height of the trapezoid. That's 3. Okay, so if there's a 3 right there, then there's a 3 right there. And it goes from the top of the trapezoid to the bottom. Times base 1 plus base 2. Well, base 1, 14, plus base 2. Does anybody see that one? 6. Okay, grab your calculator. 1/2 times 3 times parenthesis 14 plus 6, close parenthesis, 30. So to find the total volume of the prism, we take the area of the base times the height. So the height, once again, is the distance from the trapezoid to the trapezoid, the trapezoid to the trapezoid, the trapezoid to the trapezoid, the trapezoid to the trapezoid. We're working with 5, which gives us 150 cubic centimeters, and that's how we find the volume of a prism.